Welcome back. So, I want to continue off where I left off last time because I want to make something clear that I just realized it's not clear enough. So, let's quickly review where we left off, which was talking about center of gravity, what happens when you apply a force through the center of gravity versus away from it with our example of our pencil. So, again, if you remembered last time, we were talking about how if we had a pencil with a center of gravity here, and if you applied a force that went through the center of gravity, then that would result in a motion that we define as a translation. It's just moving the object. So that again is just translation. And again, that happens when you apply a force through the center of gravity. Now, if you recall, I mentioned how if I were to apply a force at this edge, that would result in a rotation as well. And again, I mentioned, well, if you had another force on the opposite side that was of equal amount as the first one we applied, then that would also result in a rotation in the opposite direction where pretty much they both cancel each other and you're still left off with a simple translation. Now, you might have caught this when I mentioned it, but I didn't make it clear enough, so that's why I'm revisiting this subject or this topic. If I only had this force, then again, I have that rotation, but I still have the translation. So again, a force being applied away from the center of gravity results in both a translation plus now a rotation. That's the part that I wanted to kind of make clear because I didn't like how I kind of left it off last time. I don't think it was clear enough, but now I think it is. So let's move on with the topic for today. So what I wanted to talk today about was again building continuing to build on in terms of rotations as a result of forces being applied away from center of gravity, but now in reference to a plane, a glider specifically. So in order to do that, we have to start by defining where the center of gravity for a plane is. So if I start drawing my glider around this pencil as such and start erasing where my pencil was, and you start to remember what the definition of center of gravity is, which is the average location of the weight of the object, you might start realizing that as I finish drawing my glider, the mass distribution, or as you might say, the weight, is shifting. And it's shifting towards the front because now you're going to have the weight of, the pilot, you sitting in the front, the structure of the wing, the structure around your, cabin where you guys are sitting. It's heavier. In the back, you have your vertical and horizontal tail. They're tiny when compared to the structure of the front of the plane that has the wing and everything else. So your shift in center of gravity shifts forward because again the shift of weight is now towards the front. But our definition of how forces act on the center of gravity and all that stuff remains the same. And what do I mean by that? What I mean is that again, if you apply a force that will go through the center of gravity, that will result in a simple translation. But now if you apply that force away from it, then you're now going to have a translation with a rotation. So in this case, what direction is the rotation? Again, if you're looking at the nose of the glider, is it going to be pointing up to the sky or pointing down to the ground as a result of the force that I'm applying in the back? If you said it's going to end up pointing towards the ground, then you're correct because this is going to cause it to rotate that way. The nose is going to end up pointing down. But now, as we have determined where the center of gravity in a plane is, I could start moving into the next topic, which is looking at rotations and how we define them. And in order to do that, we need to start looking at the coordinate system of the plane. So we're going to start with that first. So the coordinate system of a plane will be referred to as the body axis. And again, that's basically identifying the direction of like x axis, y axis, and z axis, but in reference to a plane, or in this case, our glider. So if I quickly look at the top view of a glider, so if I say that my fuselage is some shape like that, my wings are somewhere towards the front, and my tail is back here. The axis that we'll define as the x-axis is going to be going through the fuselage, pointing forward, will be our longitudinal axis, or also we'll refer to as the x-axis. But what I want to make clear right now is, again, that's going through the center of gravity, and it's again connecting the tail of the plane to the tip nose of it. Now, the second axis, which in this case would be our y-axis here, is referred to as the lateral axis. And again, it's simply connecting the two tips of the wing, but it's going through straight through the center of gravity, which is our blue dot here. So these are two two axes out of the third. The third one is pretty much coming out of the screen. So that blue dot is pretty much like if you put your pencil eraser top on it, then that axis coming out of the screen is now your vertical axis. So if you look at it from the side view, I'm just going to put it up here. If my red was my longitudinal axis, and again, my center of gravity was here, then my vertical axis is pointing up into the sky, and that's my vertical axis, or also what we'll refer to as the z axis. So again, the body axis is the reference of the plane's axes that go through the center of gravity. So longitudinal is going through the fuselage, meaning it's connecting the tail to the nose of the plane. The lateral axis is connecting both tips of the wing from one side to the other, and it's also going through the center of gravity because the center of gravity is the origin of this coordinate system. And the vertical axis is basically pointing down to the ground or up when the plane is flying straight and level. But again, as the plane is rotating, so let's say it's no longer um, flat to the ground, that vertical axis is always going to be wherever you basically tilt your head up and look up through the glass. That's always going to be positive up z axis. So this coordinate system will move with the plane as it's rotating, as it's pitching up, down, rolling to the left, rolling to the right. This coordinate system is always a fixed reference point to the body of the plane. Again, that's why we're referring to it as a body axis. So now that we have our coordinate system of the plane, we now need other reference points to be able to start defining what like a yaw angle is, for example. So let's start there. Yaw angle. So you've, we've determined what the longitudinal and lateral axes are. They're part of the body. The flight path is always going to be the direction in which the plane is moving towards. So even though your nose may not be pointing in the direction that you're flying or moving in the sky, the flight path is always the reference of where the plane is moving towards. So the easiest analogy is pretty much as you're walking somewhere, if you're facing the direction you're walking with your face, like looking in that direction, that's your flight path. Now, if you're still walking in that direction, but you decide to turn to your right because you saw like a cat run by, and you keep walking the direction you were, but now you're rotating your head to the right. Now you're looking away from your flight path. You're still walking in that original straight path before you turn to look at the cat that ran across in front of you. So if your head in that direction that you're looking at is technically now your longitudinal axis, then the angle between your flight path and your longitudinal axis, we're going to define it as your yaw angle. So it's pretty much the motion of your face rotating or turning to the left or to the right. That's basically our yaw angle. Now, our next angle that we're going to look at is our pitch angle. But now we need another reference point because the flight path is not really going to help us here. So what we're going to look at is, well, if the ground is a reference point and it's flat, if we are then pitching up, meaning we're looking into the sky, then the angle made between the longitudinal axis and the ground axis will be considered our pitch angle. And again, that's the angle made between those two axes. So if you end up looking up to the sky as you're flying, then we're calling that a positive pitch. If you then pitch down, meaning you're going to start looking towards the ground, that's a negative pitch in our case. Now, crazy thing is, if this plane was flying upside down, then again, positive could still mean moving downward. But again, it's because you flip your world upside down. But we don't have to worry about that because we're not doing any maneuvers that's causing you to be upside down. So just remember, pitch up means you're looking more up in the sky. Pitch down, you're pretty much looking into the ground. Now, in modern planes, not in the glider because it doesn't have that fancy dial, this is where you'll have like your horizon dial, where you'll have a section where the top is maybe like colored in blue, let's say, to indicate the sky, and then the bottom might be some like reddish, brownish color. And again, it's kind of like helping a pilot understand what how the plane is like. Is it pitching up or is it pitching down? And again, this red line that's going across, we refer to it as the horizon line. So again, as you're looking out straight through the window of the plane, you could see your horizon. But if you start ending up seeing more sky, then that just means you're pitching up. Versus if you start seeing more of the ground, then you're pretty much looking down on the ground, and that's a negative pitch. So again, that's how we're going to define our pitch angle. But one thing that I want to mention, and don't worry about it, we'll talk about it later, but I'd like you to think about is there's another reference point for pitch. If we consider the fact that gravity always points down, and we know the acceleration of gravity is always constant, because that's a physical law, then if our vertical axis is still, again, it's going to rotate with the plane. So if the angle of the aircraft is pitching up, your vertical axis is still going to be looking straight up into the sky, in the sense of like if you tilt your head up and look through the glass, in that direction is always positive vertical for us in terms of the plane, the body axis. So if the axis of the vertical is off from the gravitational axis, there's actually a sensor in your phone that will be looking at just the vertical axis acceleration. So if that acceleration is now different than your gravitational acceleration, then there's a mathematical way to use, sines and cosines to determine what that angle is. And that's something that I want you to think about, because yes, our sensors on our phone will capture and tell you the pitch and roll angles automatically. But let's say if that sensor fails, how could you then use the accelerations rating sensors to determine your angle of your plane as well? So that is something that I want you to consider, because I would like you to be able to calculate that. in the event that I say, hey, assume that your roll angle or your pitch angle is gone, it's dead, it died in flight, but you still have your sensor that determines what the accelerations of the axes are, define them for me. Define what now the pitch or the roll angle is by that information. So that's why I said I'd like you to think about that. But let's look at our third angle now, our roll angle. So again, if our reference was the ground and you're now tilting or banking to the right or banking to the left, the angle between the ground reference and your lateral axis, that angle difference would be a roll angle. Now, for the sake of now, let's say that again, that blue dot with the X is basically saying that the axis of your longitudinal is coming out of the screen. So if you had a pencil with you and you put the eraser tip on the blue circle with the X, and the tip of the pencil is now pointing out towards you, and I say rotation clockwise of your pencil is a positive angle and counterclockwise is negative, I'd like you to think, what is this angle? Is it positive or is it negative? So, one way to kind of think about it, stick your arms out just like this. I'm the plane now. Grab a pencil, and that pencil's pointing forward is my longitudinal axis. If I'm rotating to the right, which again, my video feed is going to flip it, so I'm rotating right, even though it looks like I'm going left, but trust me, I'm rotating right. My pencil's motion for that is clockwise. So rotating right is positive, left is negative. And again, the easiest way I could think about is if you hold a pencil, and again, this is your axis of longitude. If you rotate it to your right clockwise as you're holding it, then that is a positive rotation. So in this image, this rotation that is being shown here is a negative roll. Again, this might be difficult to understand or grasp the first time, so feel free to watch the video again or just pause it and take a time, to think about it. So again, we've talked about pretty much three angles already. Your yaw, pitch, and roll. And again, for yaw, we're simply looking at the flight path versus your longitudinal axis angle. So this angle here. How, it's basically we're defining this angle as a yaw. Now, technically, the axis that's being rotated, if you really think about it, if your pencil, again, if you put your pencil's eraser on the screen where I have that blue circle and the X, and you rotate it clockwise, so meaning as you rotate clockwise, the longitudinal axis is rotating like if it were a clock hand. That is a positive yaw. So rotating clockwise, if you put your pencil on that blue dot and you rotate that pencil clockwise, you're rotating about your vertical axis. Your vertical axis is the one that's spinning and it's causing this yaw to be created. And again, the yawing was the reference between the flight path and the longitudinal axes. For pitch, if this is your longitudinal axis and we look at the ground, let me change it actually. Let me say this is the ground. And now this is your longitudinal, so it's pitching up your plane. Then what axis are you actually rotating about? Think about. So it's the same thing as before. So now if here's my center of gravity, and if you put your pencil, again the eraser, on that black dot now, and you start rotating it, what axis am I rotating about? Again, if you think vertical, I would say nope. That would have been yaw. So what is the remaining axis that we are not looking at right now? Lateral. So that's the rotation of your lateral axis that would result in the pitch of your plane. And finally, for roll, if we are looking at your plane, and again, let me go to the slide to show you again. So here's your plane. The ground is that green line. Your red line being shown is your lateral. And that blue dot, if you put the tip again of your pencil and it's sticking out of the screen and you rotate it, what axis are you rotating about? Is it your vertical? Again, no, because for vertical rotation, that would be the yaw. And we just said that for pitch, that's your longitudinal. So the remaining one is what? I mean, we said for pitch, it would have been your lateral. So your remaining is what? Your longitudinal axis. So again, we've just pretty much defined our coordinate systems and their reference points of how we're going to determine roll, pitch, and yaw. So just a quick review. So here's my 3 axes. Let's just say, again, this is my longitudinal here, which again, if you remember, we're going to say that was also x-axis. Let's say here is my lateral axis, which we said it was a y-axis. And up and down is our vertical axis, and that's the z-axis. We're saying that if you were to rotate about the vertical axis, that would result in yaw. If we rotate about our lateral axis, that will result in a pitch. And if you rotate about your longitudinal axis, that will be a roll. Now, don't worry, later on, and even in your documentation that you'll have, I'm going to show you the same rotations and directions of being pointing and everything in terms of the phone that's collecting the data. So again, we've talked about these axes in reference to a glider, but I'm going to explain what the axes are on the phone so you make sure you line them up. Because again, you want to make sure your axis of your phone and that of your body of your plane are on top of each other so that the recordings of the phone are pretty much the recordings of what the plane's body axis would be. But now that we have actually defined roll, pitch, and yaw, and the reference axis of the body and the ground and the flight path, we could actually start looking at, okay, well, how are forces being applied to, again, the center of gravity through the vertical tail, the horizontal tail, through the wings to cause these motions? What are these surfaces that the glider uses called? How are those forces acting upon, and what are the reacting forces or moments, pretty much rotations that are being caused through this? So that will be the next video. Again, in this video, we were simply wanting to look at what is the body axis of the plane, where's the center of gravity now in terms of a plane, but building up to how, again, a plane is able to maneuver in the sky, but we're going to start combining everything. So, again, center of gravity, first law of Newton's law, and of Newton's law of motion, the first one. But then in the next video, now that we have all this information, we could actually start talking about another law of Newton, which is Newton's third law of motion, and how that relates to flight, and how when wind interacts with the plane surfaces to allow it to pitch up, down, roll left, right, or yaw, to the right or to the left. So again, we're gonna start putting all the information together, but again, it's a lot of information, so I'm trying to split it as much as possible to kind of give you a better example of, not a better example, but build up the information.